Welcome back, and today we shall discuss about regression algorithms in machine learning. So let's start with the introduction of what is regression algorithms. Actually, regression algorithm and classification algorithms, they are used to solve the supervised machine learning problems. So classification algorithms are already being done. Referred, I will provide the link and the end screen. In the end screen, you can find that. So we'll be discussing about regression algorithms. So here, regression, as the name suggests, it deals with the continuous data, unlike discrete data, which we have seen in the classification algorithms. So this continuous data is in the form of range or interval, wherein you have groups. You've got like 0 to 1, 0 to 10, 10 to 20, and so on. This is how you group the continuous data. You don't have a discrete value for that, like 0 or 1 or A or B or C. Like they cannot be grouped into a whole number, a whole digit, or a discrete complete data. So now I walk you through the example to make it more clear that few regression problems are like predicting house prices. And we've done one machine learning project on this is Boston housing price detection or prediction. And since these prices are in a continuous range like 10,000 to $20,000, 20,000 to $25,000 slab, so this is coming under the regression problem. The second is weather conditions, wherein you have to predict the weather conditions and it is not discrete because it again comes in interval like 33 to 35 degrees Celsius. It is not very certain. We have to predict it. Then another example is stock prices, wherein you have to predict, which is again very uncertain market, and this prediction again goes high or low. And an age group also is also a continuous example or a regression problem. So now moving on to our different types of regression algorithms, and firstly is the linear regression. So I'll walk you through linear regression. This is the most widely studied algorithm since decades, and it has been used in statistics, and now it is being used in machine learning. It is the earliest, or you can say the first um, regression algorithm that we'll be dealing with. Now, this is very simple algorithm as this tries to fit your data in a form of a linear function, in a form of a linear model. So what it does it is the model assumes a linear relationship between the output and an input variable. And so I say that that is why it is linear, because it is trying to fit the model or the data into a linear function. And it has its many limitations also, because it is trying to fit the data into linear model or linear function, which might not necessarily be a good fit. So it might lead to a poor fit also if it is not a linear model. So now I'll walk you through the figure of this linear regression to understand it better. So you can see that this tries to fit a line, and the data points which we can see in blue dots or blue circles are the points, and this line is a line from where the variance or the error is minimum. So we can see the relationship between the independent variables on x-axis and dependent on y-axis, and the linear relationship is being mapped with this line of regression. A few examples for this could be relationship between weight and height of a person and how they are interlinked, and what is the correlation. Is it moving in the upward direction or in the downward direction? So once we build the model, we will understand linear regression in greater detail. Let's move on to different type. Another type is L1 regularization. This is also known as the lasso regression, which means it is least absolute shrinkage and selection regularization operator. So it's got a long name. Just to cut it short, we are using lasso regression or L1 regularization in technical terms. So what happens here is it is just a variation of linear regression, and this is used when the data is highly correlated. So I'll just walk you through the diagram and what it really is. See, you can see these lines. There are various data points. There are various variance in the data, and they are being merged into towards a central point. So what Lasso does, it is a process wherein the data values, they are shrunk towards a central point, and it automatically, this helps to eliminate or wrap highly correlated and redundant features in a low variance method. So this is trying to reduce the variance of a large amount of data. But I would also tell you that L1 regularization works well when you have got a small data set. Now we shall see further about this in when we do the practical exercise of lasso, ridge, and more regularization techniques. Now let's move on to our L2 regularization, which is also known as the ridge regression. This is similar to the lasso regression, but the difference is that the ridge coefficient, they are never zero, rather they are minimized. So now I'm talking about coefficient and slope and everything because they use this line of equation of line, which is y equals to ax plus c, with various variations in the values, I would say, in the parameters. So they are using this coefficient here. Ridge, the coefficients are never zero. So what happens here is that the ridge regression, it decreases the complexity of a model, but it does not reduce the number of variables. So this is the difference, and this is what ridge regression does. It is again a regularization technique, and we can use it for regression algorithms. So now let's work on to different regularization or regression algorithm, and that is called elastic net. Now this elastic net is a well combination, I would say, of L1 and L2 regularization. This takes the best from both ridge and lasso regression. So this would be more clear when we do the practical exercise of it, that how is it really best and how it is taking the best from both the regressions, and how does it really fit the data, what it is really doing. So as of now, just an intuitive knowledge about these regression algorithms. There are many other advanced regression algorithms like locally estimated scatter plot smoothing, it is multivariate adaptive regression, splines, that is MARS, stepwise regression, and OLSR, that is ordinary least square regression. So this is beyond the scope of this video as of now, because we are restricting ourselves to basic regularization and regression algorithms here. So I would just end this video here, and thanks for listening and watching, and I'll be coming up with next important machine learning terminologies and matrices. So stay tuned. Thank you.